Okay, so today we're going to talk about the trapezoid rule, and this is the ending of. We're almost at the end of applications integration unit. The idea here is, in the last couple of classes, we want to find the area under the curve. The idea is, and we know in the course we have a lot of, initially we work with like functions, like linear, quadratics, sine waves, exponentials, but then chapter like 6 through 8, we were just given a lot of data and we were, given, picture, maybe we had data. And so the computer, it can connect it with like lines and stuff, kind of looks like this. We're not really sure the function, but the question is, can we find the area under this curve? And the idea is we're going to use the trapezoid rule. And just quickly, we're going to just simply create, based on the points we have, we're going to create a bunch of trapezoids. And from these trapezoids, we're going to add these up, and we're going to come up with an approximate area under this curve. Once again, we don't know what the curve is, but we have a bunch of points, and we can create trapezoids, and we can find the approximate area. Once again, we have techniques to find the area, but this is another technique. Now, what we're going to do first is, let's first come up with a formula. So let's come up with a simpler curve. So my question to you is, the idea is you're going to take, we're starting with the region from A to B, and in general we have a function, dx. The idea was, we saw in the last picture, we're going to break it up into a bunch of, so you might say, you might be asked to break it up into n trapezoids. And so the question is, how many cuts, if you add trapezoids, how many cuts? So for example, if I want you to, if I want two regions, how many cuts am I going to make? One. So if I have a curve like this, from A to B, from A to B, we're going to make one cut to create, two sections. Or if I want, if I want three trapezoids, I'm going to make two cuts. And that's the idea. So if we want n trapezoids, we make n minus 1 cuts. Okay, let's move on. So let's take an example. So the idea here is, so we have a function f of x. We're going from A to B. Okay. Now, let's, for example, I say I want 4 trapezoids. 4 trapezoids. Okay. So how many cuts do I need? You say you need 3 cuts. So one in the center, and then I'm going to do one over here and one over here. We're going to call this first cut x1, the second cut x2, the third cut x3. We're going to rename the first cut x0 because it's like the initial beginning of our integral. And I'm going to call this x4. Okay. Well, I want to find the area of a trapezoid. So I have the height. Once again, we're going to call this y0, but it's also, plugging in, this point is f of x0. So the height of this, like the base of the trapezoid, is like f0 or y0. What's going on here? We're going to call this y1. This point is, f of x1. This is y2, or, this is f of x2. This is y3. This point is f of x3, and this is y4, and this is f of x4. Okay, well, what we're going to do now is we're going to find the area of these trapezoids. So you say, okay, well, I know the area of a trapezoid, is 1/2 the height times the sum of the bases. Now, we have our basis, For example, in this first over here, the first height and the second height are my bases. The question is, what is the height? What's the distance between the bases? Well, let's think about this. This whole distance here is b minus a. Because if this is like 2 and this is 8, the distance is 6. If this is 10 and this is 20, the distance is 10, 20 minus 10. So we have b minus a, but what did we do? We broke it up into four parts. So each of these is, if we have 4 trapezoids, each of these parts is b minus a over 4. B minus a over 4, b minus a over 4, b minus a over 4. Okay, now we're ready to put a formula together. So you say, okay, well, what's the area of the first trapezoid? You say, let's call this T1. Let's make it in blue. The first trapezoid 1 is, what do we have here? So we have 1/2, we have b minus a over 4, because and then times y0 plus y1. Okay, well, we're going to add the next trapezoid. Once you make this red, same idea here. Once again, it's an approximation. It's not exact, but we're just that's the idea of approximating. So let's see. We have plus what? Same idea, 1/2, the base is b minus a over 4. We have y1, y2. y1 plus y2. Okay. Let's do the third trapezoid. We have the green here. Same idea here. Am I running out of space? No, I'm good. So we have plus b minus a over 4. Then we have y2 plus y3. And then I'm going to do the last trapezoid in purple. We have, here's a trapezoid. We have, let's see, we have 1/2 b minus a over 4 times y3 plus y4. Can you see it on the screen there? Yeah, we're good. Okay, well, let's clean this up a little bit. So we know from earlier math, we know we can factor out the 1/2, and we can factor out the b minus a over 4. What's going on inside? Well, we have y0. How many y? We have 1 y0. And we have 2 y1s. We have 2 y2s. We have, let's see, we have 2 y3s. And we have a y4. And we get this really interesting formula, which is to use the trapezoid rule, take 1/2 times the interval length, right, times the first height plus the last height plus 2 times all the middles. And that's the trapezoid rule. So let's do an example. And once again, you got this in the formula booklet. So however many intervals you have, once again, 1/2 times the height or the interval length, the first height, the last height or the base, plus 2 times the sum of the middles. Okay, let's do an example. So, example 1. I want you to find the area, or rather approximate, using trapezoid rule, the area under f of x equals 12 over x from 1 to 4 with an interval length of 1. Okay, well, got this down. I'm going to erase this. Or I'll do it over here, actually. So this is applications. You have the GDC, so you immediately know. You immediately know what the picture looks like. You know something like this. This is the right branch. There's another branch on the lower left. We're not going to talk about that because we're only interested from 1 to 4. And I know it's from 1 to 4. Once again, it's applications. We're only above the x-axis. And I want to know this area in here. Now, once again, I can just put this in the calculator. I know at the end, I'm going to ask you to just figure out the integral, but we want to, this is the exact. I want to approximate though. So we're told that the interval length is 1. So we have, here's 2. Here's 3. Oh, my diagram's a little bit off. It's a sketch, it's not the best. So I'm going to use the formula. So let's see. I have, let's see, and I want to figure out, let's see, what's f of 1? F of 1 is 12. F of 2 is, well, 12 divided by 2 is 6. This is 12, this is 6. What's f of 3? Well, 12 divided by 3 is 4. And what's f of 4? 12 divided by 4, this is 3. Let's see, 4 and 3. So the formula is very straightforward. So we have 4 minus 1. So once again, the interval length equals 1. So 4 minus 1 over n equals 1. Therefore, n equals 3. 3 trapezoids. That's the connection. You're not really asked that. But once again, use your art skills to figure that out. And then we can use the formula. The approximate area is equal to 1/2 the interval length times the first base plus the last base plus 2 times the middle bases. And that's it. So we have 1/2 times, let's see, 12 plus 3 is 15 plus 20. We have 35 divided by 2 is 17.5. Now, I'm going to put this on pause so I can get my graphing calculator. So I have my calculator. What you're going to do is, we have an answer of 17.5. Let's look at the exact value. So once again, we know, we don't, once again, it's applications, we don't have to do it. Sorry, that's the mouse. We don't have to do it by hand, but we have technology, so let's turn our calculators on. I'm going to use the T-Inspire on. Go to the scratch pad. We're going to go to Menu, Calculus, Numerical Integral, Enter. The lower limit is 1, the upper limit is 4, and the function is 12 divided by x. Make sure you put the x in the dx. Enter. Yeah, so we got 16.6. Is this correct? Did I do something right? Yeah, let's see, 15, 20, 35 divided by 2, 17.5. The actual answer is, the actual answer is 16.6, so it's a close enough approximation. Let's try another one. Now, in this next problem, I'm just giving you a set of data. In this next problem, you just get a set of data. And this goes back to our statistics unit where maybe the next problem is you're given a set of data. So let's see, so this can be used if you just have a table of data. Now, once again, we could have created a table over here. Let's just backtrack a little bit. I mean, I figured these out here, but there's no reason why I couldn't have made a table. You know, 1, 2, 3, 4. I know this is x. This is 12 over x. This is 12, 6, 4, and 3. We have our heights. But now here we're just, like in our stats unit, we just have a set of data. So here's the data you get. We have, let's see, 4, 6, 8, 10, and 12. And we're told for 4, the y value is 5. We're told for 6, the y value is 13. We're told for 8, the y value is 10. We're told for 10, the y value is 3. And we're told for 12, the y value is 4. We're obviously the interval width is clearly, just by inspection, we can look at the x's. I could ask you, how are the x values progressing in the sequence? You go, oh, it's 2, Mr. Adler. So it's 2. And the idea is, how do we find the area? Maybe I want to first do a sketch. You know, it's not the best sketch. Let's see. Here's 4, 6, 8, 10, 12. What's going on here? Well, let's see, 13, let's see, I don't know. This is 13, this is 10, this is 5, 4, 3. So let's see, 4 goes to 5, 6 goes to 13, 8 goes to 10, 10 goes to 3, 12 goes to 4, whatever this is. Whatever this is, we can still make trapezoids. We can still make trapezoids to find the area onto this curve, right? Trapezoid, trapezoid, trapezoid. That trapezoid. Once again, I'll say it again, we don't know what this function is, but I'm making trapezoids. I'm finding the area under this curve. So what does the formula say? Okay, well, the formula says to approximate this area, right? It's equal to 1/2 the interval width, which is 2. Let me get my black pen, sorry. 2 times the first height, which is 5, the last height, which is 4, plus 2 times the heights in the middle, 13 plus 10 plus 3. And that's the trapezoid rule. That's it. Like, that's it. There's nothing. So let's see. This goes out with this. Or put it in your calculator. I'm doing a little old school. I'm doing this by hand, but don't feel you have to do this by hand. It is applications. You have a calculator. What do I have here? I have 9 plus 2 times 16, 26. 2 times 26 is 52. Therefore, the area is 61, whatever the units are. Generally, pay attention to what the units are. So it's unit squared. What is this? Like, yeah, unit squared. Yeah, once again, it's an approximation, but it's close. Helps us find the area. The last example I took from the book. Find, let me erase this. The last problem in the book says find the, approximate the area under y equals e to the x from 0 to 1 and use 5 trapezoids. I want five trapezoids. So I want you to think about that. Think about that for a second. So yeah, I'm gonna walk away. Good, I'm back. Let's think about this. So maybe we didn't study e to the x in applications. That's okay. Stick it in your calculator. So you stick it in your calculator and you see, oh, it looks something like this. This is known as an exponential function. But we're gonna start it at 1. And we're going to end at, oh no, I apologize. We're starting at 0, and we're ending at 1. And I want 5 trapezoids. If I want 5 trapezoids, how many cuts do I have to make? Well, I can know in my head I need 4 cuts, or I can know that the interval length is 1 minus 0 divided by 5, which is 1/5 or 0.2s. So I start at 0, I go up by 0.2, and up by another 0.2, go up by another 0.2. Lastly, go to the final 0.2, and then the last one takes me to 1. And so I see here, I have 5 trapezoids. Now, the question is, how do I find the heights of these? Well, let's make a table. This is 0, 0.2, 0.4, 0.6, 0.8. Well, if this is x, e to the x is simply e to the 0. Maybe you know anything to the 0 is 1, but these others, just stick it right in the calculator. E to the 0.2, e raised to the 0.4, e raised to the 0.6, e raised to the 0.8, e to the 1. E is really important. It has its own button on the calculator right here. Yeah, right here. It's really important. I think is as important, if not more important, than pi. So e and pi, it's the same idea. These are weird. They're irrational numbers, but they're really important. It's so important that I actually have it written on the board over there. E is actually 2.718, and it goes like pi. It goes on forever. It never repeats. Like these I'll use like the 6th grade terminology as you describe irrational numbers, but that's what's going. E is the same idea. And then you just use these values to find the area under this curve. You say, okay, 1/2 times 0.2, because this is the interval length, we're going by 0.2s, right? We have 4 cuts to make 5 trapezoids. The formula says the first height plus the last height. Once again, I'm putting this in my calculator. I'm just putting these numbers in the calculator. Then plus 2 times all the middle heights. Okay, e to the 0.2 plus e to the 0.4 plus e to the 0.6 plus e to the 0.8. Close, close. And what do you get? You should get approximately 1.72, and that's the area under this curve. That's using the trapezoid rule. Trapezoid, 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 trapezoid. The approximate area is 1.772. If you go to your graphing calculator, turn it on, go back to menu, calculus, numerical integral, enter, start from 0, go up to 1, do e squared, so the letter e shows up, and then put the letter x in there, and then in your differential, the d blank, put the x, and let's see what we get, enter, 1.718. The integral from 0 to 1 of, I wonder if I wonder if that's the actual answer. Hold on one second. I'll put my video on pause. Okay, so my graphing calculator, I got 1.72401, and when I did the integral from 0 to 1 of e to x dx, I got 1.71828. So we can see it's kind of close. And then IB might ask you to do an analysis, and that's it. Excellent. You're going to do the problems in the book.